Good morning to all. Today we are going to discuss about the topic magnetic flow meters. In mechanical flow meters, there are mechanisms in the path of the flow which moves continuously at a speed which is proportional to the flow, right? And there are generally used for metering liquids. However, with a certain modification, they can be designed to meter gases also. They can be divided into two main categories with a further subgroup, which are displacement type and interferential type. The displacement type are volumetric in operation. The cyclic displacement of detecting element, example piston, being directly proportional to the volume of the fluid passing through the meter during each cycle. Interferential type flow meters are current type flow meters are the measure velocity of flow from which the flow of volume of flow is interfered. When we discuss about the magnetic flow meters, which are the first type of flow meter to be considered high corrosive application and application involving the measurement of erosive slurries. Thus, meters works on the principle of Faraday's law of electromagnetic induction, which states that whenever a conductor moves through the magnetic field of the given high strength, a voltage is induced in the conductor proportional to the relatively velocity between the conductor and the magnetic field. This concept is used in electric generator. In the case of flow meters, electrically conductive flowing liquids works as other conductor. The induced voltage is given by the equation is equal to C cross P cross L cross V, where E is the induced voltage in volt, C is the dimension constant, B is the magnetic flux, and L is the length of the conductor in meters, and velocity V, which is the velocity of conductor in meter per second. The equation to convert a velocity measurement to voltmetric flow rate, Q is equal to V cross A. Here Q is the volumetric flow rate and V is the fluid velocity and A is the cross-sectional area of flow meters. From the above equation, E equal to C into B into L into V, we can write as V is equal to E by CBL, and therefore value of Q become E into A divided by CBL. For a flow meter, A, C, B, L are constants. Therefore, Q equal to K into E here, K equal to A by C, B, L. Therefore, the induced voltages is directly proportional to linear volumetric rate. And when we discuss about the construction, the magnetic flow meter consists of electrically insulated or non-conducting pipe such as fiberglass with a pair of electrode mounted opposite to each other and flush with the inside wall of pipe, and with the magnetic foil mounted around the pipe is so that the magnetic field is generated in a plane mutually perpendicular to the axis of flow meter body and to the plane of electrodes. If a metal pipe is used, an electrically insulating liner is provided on the inside of the pipe, and the basic operating principle of magnetic flow meter in the flowing liquid act as the conductor. The length L is the distance between the electrode and equals to the pipe diameter. As liquid passes through the pipe section, it also passes through the magnetic field set up by the magnetic coils, thus inducing a voltage in the liquid, which is detected by a pair of electrodes mounted on the pipe wall. The amplitude of induced voltage is proportional to the velocity of flowing liquid. The magnetic coils may be excited by either AC or DC voltages. The currently pulsating DC, in which magnetic coils are periodically energized by, is used. Magnetic flow meters are available in the size of 2.54 to 2540 millimeter in diameter, with the accuracy range plus or minus 0.5 to plus or minus 2%. The measurement taken by the meters are independent of viscosity, density, temperature, and pressure. The range of such meters may be the ratio of 3:1, but normally a 20:1 range is accepted here. When we consider a modern design of magnetic flow meter is the one which can be inserted into the line through coupling. It consists of electrode mounted on each side of the probe and the magnetic coil, which are also integral to probe. The probe can be mounted on the pipes of diameters 152.4 millimeter, and the above can easily be mounted for open channel flow. When we discuss about a few advantages of magnetic flow meter, it can handle sturdy and greasy materials. Also, it can handle corrosive fluids. It is very low pressure drop and totally obstructionless. It is available in the large pipe sizes and capacity, as well as in several construction materials. It is capable of handling low flows with minimum size less than 3.175 millimeter inside diameter and very high volume flow rate with the sizes as large as 3.04 meter. It can be used as bidirectional meter. And when we discuss about the disadvantages of flow meter, it is relatively expensive and it works only with the fluids which are adequate electrical conductor, and it is relatively heavy, especially in larger sizes. It must be full at all times, must be explosion proof when installed in a hazardous electrical areas, so that we can conclude that when the construction of the magnetic flow meters consists of electrically insulated or non-conducting pipe, and which can be considered as fiberglass with a pair of electrode mounted opposite to each other and flush with the inside wall of the pipe, and with the magnetic coil mounted around the pipe, so that magnetic field is generated in the plane mutually perpendicular to the axis of the flow meter body and the plane of electrode. And the main equations of this is equal to C cross B cross L cross V, and we know that here we are finding the induced voltage in volt, and convert this equation into the velocity measurement. We use equation Q is equal to V cross A, and from that equation we can write that V equal to E by CBL, and therefore Q is equal to EA by CBL, so that here A, C, B, L are constant, and therefore we can write as Q is equal to K cross E, where K equal to A by CBL. For That's all for today class. Thank you so much for watching this video.